So for the algebraic solution, this is not going to be for everyone. Okay, so this is just going to explain how we use this keeping track of the inequality to solve this quadratic inequality. And this is probably our least desirable method. So again, this may not be for everyone. But to solve this, we need to consider when we are multiplying by the negative. So in this case here, I want to first of all find the boundary. So we need to find the boundary. Equal to 0. Okay, so that's important. So that's the first thing I'm going to do. I'm just going to make that inequality equal to 0. And then I'm going to factor this. X plus 2, x minus 2 is less than 0. Okay, so what I'm going to then do is I'm going to solve this inequality here. Okay, I can solve it independently. Not entirely independently though. So I get x minus 2 less than 0. Solving this, I get x is less than 2. Now we have to consider what's happening when x is less than 2 and near the boundary of 2. If I plug it into the other factor, which I'm multiplying this equation by, this ends up being positive. Okay, so I'm multiplying the equation by a positive factor, which means I do not flip the sign. So I don't flip the sign here. Then I have to consider the other factor, which I can solve kind of independently. So then for that one, I'm going to have x plus 2 is less than 0. And then I'll go and solve for the x. I get x is less than negative 2. Okay? And when I look at the other factor here, when x is near negative 2, okay, I'm going to have a negative factor here. Okay, well, negative factor means then I need to flip the sign. Okay, so I need to flip this sign to get that. So I need to flip inequality. So this is kind of hard to keep track of, but this does justify then my solution that I need to have x's that are, oops, I need to flip the sign here. I need to have x's that are bigger than negative 2, but my x's also have to be less than positive 2. And the reason why I flip the sign here is because when I solve the x plus 2 inequality and get the boundary solution of negative 2, when I'm near the negative 2 boundary, this factor will be negative, which means I need to flip the sign. Okay, so again, this is not the best, I don't think this is the best way to solve this algebraically, because we have a very easy strategy already, which is to test the boundary regions. Okay, but this strategy does allow us to keep track of which way the sign is facing. Okay, but I would have to say that this is probably the least desirable strategy that we want to use. We have our graphing when we can. And even if we don't have a graphing tool, we can often know what the graph looks like. And then we also have our algebraic strategy of finding our boundary zeros and just testing the boundary regions. Okay? And then our third, and again least desirable strategy, is to actually keep track of the inequality sign and when it's flipping and when it's not flipping.